A ball dropped vertically from a height d above the ground and bounces up vertically to a height d by 2. Neglecting subsequent motion and air resistance, its velocity varies with height is. Okay. So what is they are given? They are to be given like this. That means a ball is to be dropped from how much height? D height. Okay. So this ball is to be strikes to the ground and to be bounce it back. It will be strike the ground and it is bounces back and reaches to how much height? It is reached to d by 2 height. Okay, so they have given so many velocity versus height graph. In that we have to choose a graph. Okay, clear. So if a body is to be dropped from a particular height, what type of motion is that? That is a uniform accelerated motion. Okay, so we will draw the graph. We will write the equation, that is v square is equal to u square plus 2 GH, actually GH. What is U value? To be 0, sorry, AS it will take, and here we will take it as A is equal to G and it is acting downwards, and H is the distance, also we are measuring in downward direction. So V square is equal to what you will get? 2GT we will get. Okay, this is the velocity and this is the height. So velocity versus height graph is a parabola. Next thing, if the body is to be dropping, just before dropping, the initial velocity is to be 0. Okay, then after second the velocity increases. So each time velocity increases. So when an object is to be coming downwards, its velocity increases in which direction? In the negative direction. So while coming this direction, velocity v is negative. Okay, so we can draw a graph like this. You see this graph? Graph is to be a parabola. If I am taking, this is the velocity, this is the negative velocity, this is the distance, this is the height. Initially how much is the distance? D distance. Okay, from that while the body is coming downwards, distance decreases, velocity increases in the negative direction, and the graph is to be a parabola. So we will get a graph like this. Okay, and at striking point D is to be 0. Okay, D is to be 0 and velocity is to be maximum. When you will be strike it, the velocity velocity decreases in the which direction? In the positive direction. Why it is to be the velocity is decreasing? Because there is a acceleration is acting in the downward direction. Okay, so we will get like this. So the same velocity but in this direction, in the upward direction, the positive direction, and while going up the distance will be increases, and it is to be when the velocity is to be 0, that is the maximum velocity. What about the distance? That is to be d by 2. So this is the best graph. Okay, clear? For this graph, it is a graph is similar to this. So A is the option. Clear? Now we will see type 6. A particle thrown upwards. Which is the best graph? Okay. So if a particle is thrown upwards, what about its velocity? Its velocity we can write as v is equal to u plus at. Acceleration is to be constant. If a body is to be moving in upward, it is a uniform accelerated motion, so the velocity is to be constant. So the graph is to be a straight line. Okay. When the body is moving upwards, what about the velocity? Initially the velocity is to be maximum. Okay. Going upwards, the velocity will be decreases. Okay. So going upward, if the body is going upward, velocity will be decreases. So slope of this graph is to be a acceleration. So this slope will be decreases. Okay. So going upwards, velocity decreases, slope negative. Slope is to be negative. Clear? Okay. Then next we will get the downward motion. If it will be reaches to the maximum height, the velocity will be 0. Okay. Again, what will be happen? The velocity is to be started to increase it. Okay. Velocity is to be started to be increased. Clear? So we will see this graph. This graph is to be suitable for that. You see this. Initially the maximum velocity, when the body is going upward, the velocity decreases and reaches to 0. That is at maximum height. Then again it is to be increases in the same direction. Clear? Okay. Then next we will see the type 7. What about type 7? A body is at rest. X is equal to 0, at t is equal to 0. It starts moving in positive x direction. At same time, another body passes through x0 with a constant velocity. x1 of t and x2 of t are the position at t, which is the best graph. Okay, so we will see this. So what they are given? A body is to be initially at rest, is started from origin with a constant acceleration. At the same time, another body is to be having constant velocity passes through it. Okay, so they are to be given the displacement between the two bodies, variation with the time graph, which is the best graph. Okay, so if a body is moving in a constant acceleration, what about the equation? We can write it as the first body is moving, x1 of t is equal to ut plus half into at square. Okay, initially started from the rest. S is equal to ut plus half at square. What about x? X is equal to x minus x0, that is ut plus half at square. What about the initial position? They are given an initial position is x is equal to 0 and t is equal to 0. So this is 0. And I am finding a t instant. So x1 of t is equal to, what about initial velocity? It starts from rest. So this is also 0. U is also 0. Half at square you will get. Okay. Then the next body, that is the second body, going with the constant velocity. So constant velocity means we can write it as, it will be also started from this constant velocity. That means v is equal to displacement divided by time. That is x minus x0 divided by t. Okay. So it is to be passing through the origin. So we have calculated from there. So this is to be 0. So from this will become like this. So x2 of t is equal to what you will get? V into t. This is the equation number 1 and equation number 2. If we need to find out x1 of t minus x2 of t, what do you get? That is equal to half at square minus vt. This is to be the variation. Clear? Okay. Now we will see, this is what? Displacement. I am going to find out the slope of this. Okay, slope of this we will find out. So slope is equal to what you get? This graph shows it is to be a parabola. It is to be a parabola, and I am finding the slope in the different situations. So that this is dx by dt is the slope. Okay, so what about dx derivative of this? That is half into a into differentiation of t square, that is we will get it as 2t we will get minus v into dt by dt cancel. Okay, so we will get it as slope is equal to, what you will get, slope is equal to this 2 again, at minus v. I am taking a condition, if the slope is to be 0, what is the condition? At minus v is equal to 0, so that is t is equal to v by a. If time t is equal to v by a, slope will be 0 for this parabola, this case. Okay, and another case I am to be taking, if t is less than v by a, what you will get? Surely slope is to be negative. Slope is negative. And if t is greater than v by a, what you will get? Slope is to be positive. We will get the slope is to be positive. So, in this, the graph of the slope is to be 0. So, you see this graph here in this region, the slope is to be 0 there. Okay, and when the time, that is the time here, when the time is decreases below that, what is the slope is decreases. Okay, then what about if the time is greater than that? The slope is to be increases. So this is the best graph. Okay, C is the option. This is A, B. So C is the answer for that. Clear? This is about the type 7. Now we will see type 8. They are given a displacement time graph. Choose the velocity time graph from this. Okay. So here the displacement time graph is a parabola. If the displacement time graph is a parabola, what type of motion? That is to be a uniform accelerated motion. Okay. So for a uniform accelerated motion, we can write the equation is v is equal to u plus at. This equation is a straight line. So velocity versus time graph of a uniform accelerated motion is a straight line. So what are the graph of straight line? These two graphs is to be the possibility. Okay. Then next, here you see that here, and one more thing is that slope of the displacement time graph is velocity. Okay, here what about the slope? Here the slope is to be 0, so the velocity is here 0. What about this region? You see here, in this region up to this region. What about this region up to this? Up to this, you can get that the velocity is to be decreasing. You see this? The slope is to be decreasing here. You can draw it like this. Okay, so while going upwards, what? The velocity will be decreases. Here the velocity is to be decreases. That means initially maximum velocity, while going upwards it is to be decreases and reaches to 0. Here you see that initially this much is a slope, but here it will come slope is increases. That means velocity increases. So here this case velocity increases. Clear? So we can choose which is the graph. This is the graph. Velocity is initially maximum. It is to be decreases and reaches to 0. Again increases in the opposite direction. Okay. This is the graph of a body is to be thrown upwards. Initially the velocity is maximum. It reaches to decreases and reaches to 0. Again what will be happen? The velocity increases in the opposite direction. Okay. This is the graph of this. Okay. So this is the correct answer for this A option. Clear? Next we will see type 9. What is the type 9? They have given an acceleration time graph. Choose the velocity time graph from this. Okay. So area of the acceleration time graph is change in velocity. Area of acceleration time graph is change in velocity. Here in this area, in what time? Up to 0. In between 0 to 2, what about the area? Area is equal to what you will get? That is, it is a rectangle. You can take out this area. So this area is equal to 3 into 2. That is equal to 6. So change in velocity is equal to 6. What is change in velocity? Final velocity minus initial velocity is equal to 6. We will take it as initial velocity is equal to 0. So what about the final velocity? Final velocity is to be 6 meter per second. Okay. So this is the case. Next, what happened? From that velocity, you see the acceleration is to be negative. That means negative acceleration is happening. Okay. So listen here. Up to 2, the acceleration is constant. So the body will be initially at 0. The velocity increases and reaches to maximum 6. If the acceleration is constant, the graph is to be a straight line, because if the v acceleration a is constant, we can write the equation v is equal to u plus at. Okay, this is the equation of a straight line. So this is the best one. You see this, initially 0, graph is a straight line, velocity time graph is a straight line, so that acceleration is constant. At maximum velocity, how much? That is to be the 6 meter per second. Next, what is to be happening in this area? You see this area? I'm going to find out that area. That area, what you will get? That area is equal to how much? Minus 3 into, I'm taking this time interval, that is 4 minus 2. 2 you will get, that is minus 6. So change in velocity, final velocity minus initial velocity is equal to minus 6. What is the initial velocity? Here the initial velocity is 6 itself. So Vf minus 6 is equal to minus 6. So Vf is equal to what? 0 meter per second. Okay, so Vf final velocity is to be 0. So in this graph you see that constant retardation and the velocity is to be decreases and it is reaches to 0. So this is the best graph.